Ham class, we're going to move into vertex form. We've done our transformations. We started with translations, shifting up, down, left, right on the coordinate plane. And then we did the dilations where it was either a vertical stretch or compression, or it was a horizontal stretch or compression. So now with vertex form, we have this form of a function that shows us the vertex right away, and then it shows us what angle the graph is at, or which way the parabola is pointing up or down. Mr. Collins asked her class, or sorry, Mrs. Collins, my fault, Mrs. Collins asked her class to graph the function g of x equals 2 times the quantity x minus 3 squared plus 1. Using your knowledge of transformations, describe how each part of g of x, highlighted below, will affect the parent function of f of x equals x squared. Then complete A through C. So how will this change the parent function? Well, we know that this right here, when we add plus 1, that's going to shift the function up 1. This shifts it up 1 space from here up to here. And this right here means a horizontal shift to the right. Horizontal shift 3 right. And this right here is a vertical stretch. So vertical stretch by a factor of 2. So when there's a vertical stretch, that parabola is going to be skinnier. It's going to be narrower than f of x equals x squared. It's going to be skinnier, narrower than the parent function. So we can find out all that just by looking at these numbers. So we can also sketch a graph of g of x. And that graph will go, what's our vertex on this? Our vertex is 3 and positive 1. 3 and 1. And the a value is going to be positive, so that means it's going to be pointing upwards. All right, so 3 and 1, 1, 2, 3, and up 1. So it's going to be around here. It's going to look something like that. Okay, so this is g of x. Find the vertex of g of x. Okay, I already did that. 3 and 1. Where do the values of the vertex appear in the equation of g of x? And we could put the x and y coordinates of the vertex are the horizontal and vertical shifts of the function. The function g of x is written in vertex form, which is described below. Complete the box and then use the definition of vertex form to identify the vertex of each function in the table. Looking at this, h and k is the vertex. So h is the x value, k is the y value. And the value of a right here, this a, the value of a determines which way the parabola opens. And it also determines how wide the parabola is. Because if the absolute value of a is greater than 1, then the parabola is going to be narrow. If the absolute value of a is between 0 and 1, then the parabola will be wider than the parent function. So it determines how wide the parabola is. Okay, and we could just look at these and then plug in what the vertex is. And the vertex we can see is 5 and 2. The vertex here, we have a -6 and a -4. And this time we have a +10 and we have 0 because there's no constant here, so it's just 0. And how do we know if it's a minimum or maximum? Let's look at the A value. So remember, we could look at the A value and know that if A is positive, that parabola will point up, will open up. If that A value is negative, the parabola will open down like that. Okay, so this is going to open upwards. It has a minimum of 2. And this A value is positive. It's going to open upward. It's going to have a minimum of -4. And this one has a negative value, so it's going to open downwards. It's going to have a maximum of 0. Okay, hope that was clear. And now let's move down. I'll go ahead and just do the first two. The vertex right here, we can see it's a 4 and a +5. F of x, okay. Rewrite the function in standard form, okay. So we just have to distribute here. We're gonna have x minus 4 times x minus 4 plus 5. We're gonna distribute here like we're doing FOIL because this is 2 binomials. Or you could think of it as distribute the first term and then distribute the second term, and then we combine like terms. So we're gonna have x times x is x squared, x times -4 is -4x, -4 times x is -4x, and -4 times -4 is +16, and then we're gonna add on our constant, and we're left with x squared minus 8x plus 21. X squared minus 8x plus 21. Okay. Describe how you could prove that the vertex form and standard form of each function above are equivalent functions. Well, we can always graph. When in doubt, graph it out. When in doubt, type it into your Desmos calculator, your Desmos graphing calculator. So graph both functions. To see if they are the same function. Okay, see if those two parabolas are identical. Let me do one more here. Do one more with you. Number 2, what's the vertex? And we have a -2. And we don't have a y value present, so that's just going to be 0. All right, now let's distribute x plus 2 times the quantity x plus 2. And we're going to get x squared plus 2x plus 2x plus 4. Now we can multiply. And we get 3x squared plus 6x plus 6x plus 12. And we get here finally 3x plus 12x plus 12. Okay, so I've done all but one question right here on the first side. And let me do a little bit more on the second side. Vertex form can be used to write quadratic equations when given the vertex and another point on the graph. Okay, so in this case, we're gonna actually plug in 1 point in addition to the vertex. We can find the vertex pretty easily, pretty simply by looking at vertex form, but we can also add in 1 more point on that graph if we like, okay, if we need to. So here's the steps to writing equations using vertex form. So when we have to plug in another point, here's our steps. We plug in the vertex and the values of the given point. X and y into y equals the quantity x minus h squared plus k. That's our vertex form again. I'm gonna circle that again because I always like to have the template or the parent function visible. And then we solve the equation for a, and then we substitute a back into the vertex form, substitute a and the vertex into vertex form, and then rewrite it in standard form if necessary. Okay, a lot of steps there, but I'll walk you through it step by step. Function g has a vertex at 1, 1 and passes through the point 0, 2. Write an equation for gx in vertex form. Give me just a second here. Okay, yeah, I knew I wrote it down somewhere. Okay, we're gonna write it in vertex form. So we have our parent function is f of x equals a times the quantity x minus h squared plus k. And then we're gonna rewrite it as g of x equals x minus 1 squared plus 1. So I just plugged in those values from the vertex, and now I could plug in the values of that given point, and we're going to use 2 for y. 2 equals, and we're going to use 0 for x. Sorry, okay, I'm going to put my a right there. 0 minus 1 squared plus 1. And we get 2 equals just breaking it down step by step. Negative 1 times itself gives us positive 1. 2 equals a plus 1. And we're going to subtract 1 from both sides. And we get a equals 1. Okay, what's that it? A equals 1. And once we write this in standard form, sorry, I'm just looking at my notes from earlier. Yeah, when we put this back in, actually it doesn't say put it in standard form, write an equation for, okay, so if we write this in vertex form, it's just g of x equals x minus 1 squared plus 1. Sorry, that was all they wanted. Okay, I did too much. All they wanted was those values plugged in to this function. Okay, so that was it.